Consider the limit as x approaches 2 of 1 over x minus 2 squared. So I can graph the function f of x equals 1 over x minus 2 squared, and it looks something like this. And what you'll notice is there's an asymptote at 2. So the graph, as it gets closer and closer to 2 from either side, increases without bound, keeps going up and up and up. So this kind of limit is a little bit unusual. It doesn't appear to be approaching anything. So if we look at some values maybe coming from the left, so we're approaching 2, so if we look at 1, 1.5, 1.9, 1.99, and 1.999, and then look at the values of the function, we see that we get 1, 4, 100, just keeps growing and growing, getting larger and larger. And we see the same kind of behavior as we approach 2 from the right. So if I start at 3 and then go to 2.5, 2.1, 2.01, and 2.001, you see a similar kind of thing. So this limit does not exist. It just keeps, as the function, as we get closer to 2 here, the function just keeps getting bigger and bigger and bigger, just keeps growing and growing and growing, and so it doesn't approach anything. But it doesn't approach anything in a very specific way. It keeps getting bigger and bigger and bigger. So we have some notation for that. We can say that the limit as x approaches 2 of 1 over x minus 2 squared equals positive infinity. Now this positive infinity is not a real number. It's a concept that just as a way of explaining how the limit does not exist. Let's look at another example. How about the limit as x approaches 2 of 1 over x minus 2? So again, I can graph the function f of x equals 1 over x minus 2, and I get something that looks like this. Again, I have an asymptote, but now you see a little bit of a different behavior near 2. As we come in from the left, it seems like the function decreases without bound, and as we come in from the right, it seems like the function increases without bound. So once again, the limit does not exist, but now we can say something a little bit different. We can say that the limit as x approaches 2 from the left of 1 over x minus 2 is negative infinity, while the limit as x approaches 2 from the right of 1 over x minus 2 is positive infinity. So overall, if we just want to talk about the limit as x approaches 2, the most we could say is that this limit does not exist. So let f be a function and a real number, and well, let's define these infinite limits. So first, if we have increasing without bound. So the limit as x approaches a from the left of f of x equaling positive infinity, that means that f of x increases without bound as x approaches a from the left. Similarly, we have a definition for when x approaches a from the right. And if we have both the limit as x approaches a from the left equaling positive infinity and the limit as x approaches a from the right equaling positive infinity, then we can just say overall that the limit as x approaches a is positive infinity. And then for decreasing without bound, you'll see that we have 3 very similar definitions. Keep in mind, like I said, these values of positive infinity and negative infinity are not real numbers, they're concepts. So to really drive that point home, I just want to make this explicit. Plus infinity and minus infinity are not real numbers. For example, this positive infinity, that's a concept used to indicate a particular way in which a limit fails to exist. So what I mean by that is that you can't say things like plus infinity minus plus infinity is 0. That's not true. We don't treat them like real numbers. Okay, one more example. The limit as x approaches pi over 2 of the tangent of x. And so again, I could graph the function f of x equals tan x in order to figure out what this limit would look like. And when you have these infinite limits like this with asymptotes, oftentimes the best procedure is to just draw a quick sketch of a graph, and that will show you the behavior of the function. Or if you can't do that, you can plot a couple values and just kind of see what's going on if you happen to know that there's an asymptote located at that position. So here's the graph. We know tangent has a whole bunch of asymptotes, and in particular at pi over 2 there is an asymptote right here, a vertical asymptote. And so we would expect that as we approach pi over 2 from the left, we go to positive infinity, while we approach from the right, we should go to negative infinity. And in fact, that's what we find. So the limit as x approaches pi over 2 of tangent of x does not exist. Remember, when I say that the limit as x approaches pi over 2 from the left or from the right equal positive infinity or negative infinity, this also means that the limit does not exist. It's just that we're specifying a particular way in which it does not exist. And since we don't have the same thing here. We have a plus infinity here and a minus infinity here. The overall limit as x approaches pi over 2 does not exist.